Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, we're gonna do a exam question for underwork energy and power. So this will be number three. Remember in the previous video we did number two rather, based on the experiment. Now in today's video, we're gonna do number three. So it reads as follows. So we are told that a constant force is applied at an angle of 30 degrees. So remember that force should be constant to the horizontal on a grade again of mass 6 kg that is initially at rest. Very important. Initially at rest. Remember what does initially at rest tells us? Tells us that the initial velocity is 0 meters per second. That's the information we are given. Now, a constant frictional force of 10 newtons. Frictional force of 10 newtons acts on the crate as it moves from rest at point A along a horizontal surface to point B. Now, the distance between A and B is 1.5 meters. This is the distance covered. The speed of the crate at point B it is 2 meters. This is the speed. All right. So let's just write our information here. We are told that we have frictional force of 10 newtons. We have frictional force here of 10 newtons. Then we are told that here at A, our initial velocity it is at rest again. So we know initial velocity it is 0. Here it is how much? 2 meters per second. Remember now this force here can be broken down into Fx as well as what? Fy. Fy. Again. But remember, Fx rather is the one that is doing work, as well as frictional force is the one that is doing work. This one I will always emphasize, but this is our last video. But from our previous video that we've been doing work, energy and power, I always emphasized this, that only the parallel forces are the ones that are doing work. All right, I think that's all that we have. All right, let's do 5.1. Let's just answer the questions. 5.1, they say define work done by a force. Remember work done by a force from the first video we were given again. So it is the what? The magnitude of the force and uh, there is something that's missing here. It is the product of, it is missing here. At this point, there is missing this. It is the product of, let me just rewrite this. Let me just rewrite this. We are saying it is the product of the magnitude of the force and the magnitude of the displacement and the angle between them. Okay, this is the definition. Please use the definition from the exam guideline if it does not say this. So what's important, it is the product here of the what? Of the magnitude of the force and the magnitude of the displacement and the angle between them. So from the formula, remember it is what? Work, it is given as force, the product of the force, magnitude of the force, product of the magnitude of the displacement. This is change in x, then multiply by the cosine of the angle. So from the formula here, you can define. All right. Now let's see 5.2. 5.2 says, draw a labeled free body diagram showing all the forces acting on the crate as it moves. Now, 4 marks. Again, 4 marks for forces. 4 marks for forces. Let's do this. I think this one everyone should know. Uh, the first one that I always like to mention, it is FG. Then the second one, it is my normal force. And remember, we only have normal force if our object is acting. You can say Fn, but I prefer saying N. I prefer just saying N instead of Fn. N. And then we are told that we have frictional force. Agir. And now we have an applied force. Applied force, force F. I think it is labeled as force F. Yes. With an angle of 30 degrees. This is your 4 marks. This is your 4 marks. This is what was your 2 marks. Now, despite this is what you are required to do when you are asked to calculate to draw a free body diagram. But as for the purpose of calculations, we're gonna break this f into its components. So we're gonna have our little uh, sketch here for the purpose of our calculations. Normal force, friction, frictional force here. Then I'm gonna have f in the x direction, and now I'm gonna have f in the y direction. Then this is my normal force, my friction. But remember, when I'm required to calculate something, I'm gonna use this. Anything that has to do with Fy, Fn, and Fgi, it is not important. It is of no importance. Now let's look 5.3 says now use energy principles. Energy principles only. Meaning they are trying to say do not use maybe vertical projectile motion formulas. Calculate the magnitude of force F. Now, remember here, energy principles, there are 3 of them. W net, it is equal to change in K. The master, that always works. Work done by non-conservative force. You should have conservative force. Change in K plus change in potential energy. The last one, mechanical energy at A, it is equal to mechanical energy at B. But in this case, this one cannot be applicable. This formula, we cannot use. We cannot use this formula here. Why? Because our system is not isolated. There is friction. Again, so we can either use this one or this one. Now, one thing I've realized is that on 2 videos that I've recorded under exam questions, I haven't been using the formula for work done by non-conservative force. So today, we will use it so that people cannot say I'm being stereotypic on the other formula. So remember, we are required to calculate the what? The work done by, or rather the friction. Not the friction, rather, the force. Again, force F. Now, we're going to use work, and they've told you use energy principles. So let me do this. For step 1, I'll use W net, it is equal to change in K. Then for step 2, because I like to forget a lot, step 2, let me write it somewhere here. Step 2, I'll use work done by non-conservative force, it is equal to change in K plus change in U. I'll show you how these formulas are similar in a way. So whichever that you use. So here we're gonna say wnet. Let's just let's do this. Sorry, let's do this and come and paste it here. All right. All right. Then what our wnet? It is all the forces that are acting there. Force in the x direction. I'm labeling that we are going to use F in the x direction, this one, because it is the one that is doing what? Doing work. So I'm going to say force in the x direction plus work done by friction. It is equal to what? Half mv squared final minus half mv squared initial. All right. Now, do you all agree with me that this one is going to equal to 0? Why? Because our initial velocity here, it is how much? It is 0. We all agree. Yes. So when I substitute further, it's gonna be a what is fx? Okay, let's just say fx multiply by change in x cosine of my angle plus friction multiply by change in x cosine of my angle. It is equal to half mv squared final minus 0. Just include this if you avoid substituting here. All right. Now, what is f of x? Remember, if I'm having my force acting like this, and this is my force, I'm going to have F in the x direction, F in the x direction, and I'm going to have what? Force in the y direction. So if my angle here, it is 30. So if I'm looking for this one, I know that opposite to my angle, this is my opposite. Then this is my height. Then the last one, it is rj adjacent. So if I'm looking for f of fx, it's going to be what? It's going to be adjacent divide by, we always use hypotenuse because it's the one that we're looking for. Hypotenuse. That is what it is, cos of our angle. So when I'm looking, we know adjacent, it is what? F of x in this case. What is hype? It is f. So I know when I want f of x, it is equal to f cos 30 degrees. Some people still do not know this even today. So for that, I'm gonna do it. So we know that f of x, it is f cosine of that angle. So it's gonna be a f cosine of 30 degrees multiply by what is my displacement. My displacement, I think it was 1.5 or 1.2 between the two values there. 1.5 1 comma multiply by 1.5 meters, then cosine of 0 degrees because it is moving in the direction of the displacement. Now our object, it is displaced from point A towards the right to point B, and our force, it is also acting in that direction. Again, then let's see. We have what? A cosine of 0 plus my frictional force. I think it was 10. It was 10 there. Changing x 1.5 cosine of 108 minus half. What is my mass? Oh, what is my mass? My mass, I think it was 10. Let me do this. Move it here. It's fine. Yes. Half what is my mass? I think it was 10 or 6. 6. Then my velocity final, it is 2 squared. Then I don't know, when you use your calculator there, this is where's my calculator? Let me quickly fetch my calculator. What I'm gonna do is that, okay, I'm gonna do this step by step because some people are struggling with their mathematics. So I'm gonna say 1.5 multiplied by cos 30. When I do this on one step, but for the factor, I have to think for other people. I'll just say f, then the whole substitution here, this one, it is equal to whatever that I'm gonna write here. It is equal to 3 root 3 divided by 4. So this is basically force 3 root 3 divided by 4 plus, then what's this? I think this one without the calculator, it's going to be cosine of 180, it is negative 1, so it's going to be negative 15. I think if I'm correct, yes. Oh, this one is basic math. It is equal to, this is 3 multiplied by 4, I think it's 12. So my force multiplied by 3 divided by 3 over 4 is going to be, when I take 15 to the other side, it's going to be 27. Let me do myself a mathematician here. Remember, you do not require these steps. What's important is the last step. Then I'm going to multiply uh, by 4 on both sides. Then when I multiply by 4 on both sides, I get 108. Then yeah, f is gonna be 180 divided by 3 root 3. Divided by 3, it is 36. Then 36 divided by root 3, I'm not so sure. Let me just punch this on the calculator once off. 3 root 3. It gives me a force of 12 3 newtons. But remember, in physics, you do not write your answer like this. Therefore, your force should be in 2 decimal 20,78 newtons. Now, firstly, let's just use another formula of work done by non-conservative forces equal to change in K plus change in U. I want to show you something. Work done by non-conservative force, it will be only work done by friction plus work done by other force. These are the non-conservative force. Again, we do not include any gravity. Even though we were acting on a slope like this, we wouldn't have included FG parallel. We know FG parallel acts downward, but we wouldn't have included here on this formula because FG, it is a conservative force. All right. Then what is our change in K? Our change in K, it is half mv squared minus half mv squared final, half mv squared initial plus. But what is our change in U? Remember, change in U, it is a mgh. So here we need a vertical height. A vertical height, it is how much? There is no vertical height. So our vertical height, it is 0 because our object, it is moving down. Again, it is not moving maybe upwards like this, maybe moving from here to there where there is a height of whatever number here. So here, since well it is moving just on the horizontal flat surface, there is no height. So it means what? It means that our change in potential energy, it is 0. So can you see these things are similar here? When you just remove this 0, this formula here, work done by force, work done by friction, work done, it is equal to half mv squared minus that one again. But we know this one we are talking about, it is f in the x direction. Then you do your substitution here. I know it's gonna be my frictional force, it is 10. Then my displacement, it is 1.5 cosine of 180 degrees plus force cosine of 30 degrees multiplied by displacement multiplied by cos of 0 degrees, it is equal to half 6 squared minus 0 plus 0. Remember, this is equal to 0, this, because my initial velocity is 0 again. Then when I do my mathematical gymnastics there, it's going to be F, it is equal to 20,78 watt newtons. So it is the same. So yeah, thank you very much folks for watching my videos under work energy and power. So under physics we will meet again. I think we will be doing chemistry or whatever the topic that we're gonna do. So thank you very much folks. If you really enjoyed the video, please kindly subscribe and give it a thumbs up. Thank you very much.